So for the today's discussion, I'm going to be joined by Mr. Rajesh Nath, who's the Managing Director for VDMA India, and his colleague Mr. S. Manohar, who's the Regional Head for VDMA South India. First of all, VDMA, it's the German Machinery and Plant Manufacturers Association. Mr. Rajesh Nath has more than 29 years of experience working in various industries in Germany and India. He joined VDMA in the year 1999, and since 2008, he's heading the organization as its managing director. During this period, the export of German machinery to India has increased almost six-folds, and the number of VDMA members in India now stands at around 600. Mr. Nath is also a fellow member of International Council of Consultants, member of Institution of Engineers in India, fellow member of Mining, Geological and Metallurgical Institute, MGMI, and other well-known bodies in India. Recently, he has also been accorded the Cross of the Order of Merit, the highest civilian award from the German president for promoting Indo-German trade and engineering sector. Welcome, Mr. Rajesh,
Thank
for this
you.
wonderful
Thank you.
discussion.
Pleasure to be here. Thank you.
Yeah. With this, I would also like to welcome his colleague, Mr. S. Manohar. Mr. Manohar heads the VDMA South India office covering states of Karnataka, Tamil Nadu, Andhra Pradesh, Telangana, and Kerala. There are around 200 VDMA members located in the southern part of India. He's also responsible for the woodworking division activities in India for VDMA Frankfurt and Mechanical Engineering quarterly newsletter published by VDMA India. He has around 28 years of working experience in mechanical engineering companies, telecom, healthcare, and business process management organizations in operational, sales, and marketing and strategic roles. Welcome, Manohar, for this discussion.
Thank you.
Great. So, before we get into the discussion around various topics around manufacturing, I would like to ask Mr. Rajesh about what is VDMA's role in nurturing the manufacturing ecosystem in India?
Right. Thanks, Sandeep, and welcome to everyone. So VDMA is the industrial association, the association of the German machinery and plant manufacturers. We are, in fact, the largest industrial association, not only in Germany, but in whole of Europe. It's a 127-year-old association, so carries a lot of history and support of the German industry. And we cover almost 95% of the German engineering industry. VDMA has 3,300 member companies, Sandeep, and divided into 38 industrial verticals. And the turnover of our member companies is roughly around 232 billion euros. Now, being an industrial association, VDMA has taken up topics which are very relevant for the industry, Sandeep. Topics on, like, we have a platform at VDMA, we call it the Industry 4.0 Forum. We have a platform for additive manufacturing. We have a platform for e-mobility. And we have one section which we call Future Business, where we help to give the members a sort of a forecast or a view how business would, in the next 15 to 20 years, how business would change. Besides that, as an industry association, we work very closely with institutions like Fraunhofer, the different educational institute, research R&D institutions in Germany. And I think I would like to conclude our motto, Sandeep, is humans, machines, and progress. So we believe that humans work together with machines, and machines and humans working together will lead to the progress of the society, progress of the nation, and progress of the country. So that's our motto at VDMA.
Great, that's wonderful. And you've also touched upon some of the very interesting things like the e-mobility platform, the Industry 4.0 platform, and so on and so forth. That actually, takes me to my next question, which is, what are the key automation trends do you see across the discrete industries?
Sure. Very broad question again, Sandeep. Let me try to give a little overview on this. Sandeep, if we look at the COVID, I think it's for the first time in the history of manufacturing that supply side, the demand side, and workforce has been impacted. And not only confined to a particular region, but globally at the same time. So it has had a huge impact on the manufacturing industry. Now today, actually 8 to 10% of the tasks in the manufacturing industry are automated. And this has a potential, Sandeep, to grow to 20 to 25% in the next 5 to 6 years. Now, manufacturing is undergoing a paradigm shift and with the endeavor to make it smart. Now, let me dwell a little bit on smart manufacturing, Sandeep. Smart manufacturing is an end-to-end solution of manufacturing from sourcing, procurement, processing, manufacturing, distribution, and warehousing, all coming together in an automated way. Now, communication with suppliers, communication with customers, and communication amongst the machines also, exchange of data based on the cloud technology. I think we are merging physical and virtual worlds, Sandeep, to make manufacturing more cost effective, to make it efficient, to make it sustainable, and also to make manufacturing safe. The role of smart manufacturing in the collaborating cyber-physical system brings together people, processes, and data enabled by the emerging Internet of Things, Sandeep. Now, for example, using sensors, cyber-physical systems will collect the data, analyze the data, and we are using this data or we are using that to make intelligent decisions and predict what is going to happen next, Sandeep. And this will help to automate the processes. Now, here we are talking about Industry 4.0. We are talking of industrial Internet of Things, IIoT. We are talking of artificial intelligence aided by machine learning and augmented reality and virtual reality. Now, basically, Sandeep, machines are becoming more intelligent. And I would just here like to compare machines with humans. Like we see with our eyes, we can call it sensing. Then movement of the arms or hands, that is actuation. And then we are processing with the brain, equivalent to process control. Now, machines have been performing the function of actuating. Then we added the sensors over the years. So machines were missing this component of intelligence. And now with Industry 4.0, Sandeep, the endeavor is to add the data and make these machines intelligent so that they can analyze the data. And when they are analyzing these data, Sandeep, in fact, the whole process can be made 25% cheaper. And we can also, you can say that the process can be made 30% faster with an Industry 4.0, Sandeep. Now we are also talking about closer interactions of humans and machines. Now also under Industry 3.0, Sandeep, robots were in application even in the 70s and 80s. I think the change that has happened, Sandeep, we are now talking of hobos or intelligent robots where the robots are working hand in hand with humans. And this is helping in the manufacturing process. Here I would like to draw the benefit of cobots, Sandeep, using 5D. If we look at the 5D factor, so typically for processes which are, let's say, difficult, processes which are dull, processes which are dirty, and also processes which are dangerous. And now adding the fifth dimension, the fifth D, Sandeep, is distancing and safety, especially under the COVID times. So I think here collaborative robots have a great role to play in the manufacturing industry. Now also if we are going further, for example, we can also talk about touchless automation. So we have the automated guided vehicles, AGVs, which are not only helping in shifting material on the shop floor, but also helping in fact in automated storage retrieval systems. And this has led to accuracy also safer workplace, Sandeep, because if you look at a typical forklift, there is despite of all the factors, there is always a chance of accidents happening with forklifts. And we are also talking about flexibility and reliability. And then perhaps I would like to add also the machine vision aspect, Sandeep. Now, especially machine vision. Now, machine vision is really helping when we talk about inspection of components, and looking at various industries, be it the automotive industry, be it the food processing industry, aerospace industry. I think here again, machine vision has an important role to play. Uh, so I think to conclude, Sandeep, industry will be focused on closing the loop between data extraction and value creation. Now, with digitization, we are going to generate data, we are going to analyze the data, but we are also going, we can, you could say, organize and manage this data. But it is the digitalization which is going to make it possible to draw intelligent conclusions out of the data. And I think that is where the customers are looking for intelligent and cost effective solutions. And if I may conclude, Sandeep, customers would prefer Google speed, but at Amazon rates. So that's the big contention, Sandeep.
Great. That's very insightful, Rajesh. And I really like your analogy of sense, actuate, and intelligence. And
Right,
it's heartening to know that your definition of Industry 4.0, and we
right,
at SAP also, believe that Industry 4.0 is not just confined into the four walls of the plant, but
right.
it is actually starts all the way from how you design your products, how do you plan for them, how do you produce them in close collaboration with your suppliers, how do you
Absolutely.
deliver it to your customers, and eventually how those products are being serviced or operated at your end customers. So
Right.
that's great to know. So you did talk about COVID and how COVID is actually transforming the manufacturing with the unlock the central government has announced. We are seeing that more and more workforce is coming back to the workplace. So my question to you, Manohar, is how do you think that the technology has aided this transition, and what are some of the changes happening from the shop floor to top floor perspective, keeping in mind the back to workplace?
Yeah, thank you, Sandeep. Welcome to all. I think I'll just try to take it forward from where Mr. Nath has concluded on the applications of technology for people when they come back to the workplace. And if you look at a typical manufacturing plants, now either process or discrete, since it's more focused on discrete manufacturing, social distancing was never a practice in India at all. And if you look at it, yes, unlike a process plant, which you can have people off the activities or off the processes, whereas in a discrete plant, people were closely involved in all the activities. So it is very difficult at this moment, and as Mr. Nath also mentioned, in the Indian manufacturing plants, it's only 8% of the activities that are automated. So there's a lot of potential, and these tools of automation can only help the people to distance themselves not from each other, so that they can avoid whatever the processes are going to impact them, and also improve productivity and cost efficiency across. So that's the most important thing. So I'll just quote one or two, couple of scenarios involving the automation tools that would help you to understand how it would help on the social distancing, as well as improving the automation processes of the organizations, and help them to achieve efficiency in the long run. So first, if you look at a typical plant, if you see, they're all moving. If most of the people would like to try to keep distances. Now, this could be, of course, leveraged by using the widely uh, currently used apps, mobile apps like a typical Arogya Setu types. You can create for organization types mobile apps which can prevent from people from close together and distancing close together and give an alarms across. So that's one way of keeping people away, and also to ensure that they maintain a safe distance. That's the most important aspect, so that people are not getting close to each other. Second and most important thing also is the utilization of AR and VR across. If you can see, virtual reality tools are extensively used today in the training programs in most of the organizations today. And in the COVID era, most of them are sitting at home, and off the time when they're not on the business discussion, they are on training sessions across. So virtual reality would help organizations not only to train on the future trends of automation or mechanization, but also on their new product activities also. That's one. Second, another important leverage of AR would be in the servicing activities. A typical example I can quote, I mean, a very widely quoted example is, let's assume a helicopter pilot stranded in a desert. He lands up in a desert due to a mechanical failure. Now, he might know the operational capabilities, but he might not know the mechanical capabilities of the helicopter. So how does he get over that? So he can get onto a AR glass and look at the positioning of what, and he can be thoroughly guided, provided yes, the connectivity is available to him. So he can be guided by remotely and to ensure that the helicopter is back on air. And a typical example, another synonymous to the manufacturing could be engine, engine generator set, service technician. He need not know all facets of the engineering of the engine. He can be guided on certain aspects on how to service the engine. Today, third thing would be, today organizations are moving towards mass customization or what do you say, unit productization, what you call it across. So how can this be achieved? So what would happen in a shop floor? A person, if I, Manohar, is standing on a shop floor, and if I have to do an activity, I need not be thorough in all aspects of the assembling of the activity. Let me give an example of a car assembly. I need not be knowing what all to do. So this unit car, it's actually in practice in Germany currently. A car unit can come on a AGV, auto guided vehicle, come to me. So I will all have the tools behind me what to perform the necessary activities. So then a AR screen can come in front of me, of course with my aided glasses, and then the AR screen will tell me what to do, how to do, and what is the sequence to follow. So these are some things, so people can be safe, so the AGV distance is the AGV distance between peoples on the shop floor. So that is quite safe distance, and people can do activities, whether I'm doing, okay, a leather of the car is unique, or a glass of the car is unique, or a texture of the car. So these are some of the activities that can be performed. See, what is happening currently is also, and Mr. Nath also mentioned about machine vision. Machine vision is today extensively, in fact, that is the first step that Indian manufacturing organizations started on quality assurance or quality control. First is on the go or no go. So whether the product is a go or a no go, first thing they started with the machine vision. So they had the cameras to decide with the DNA, deep neural networks, to decide whether this product is a go or a no go. Then it got extended across. So today with these cameras, you can monitor the entire shop floor and ensure the people are adequately spaced, so that if there's apart from this, I mean, there are two ways I explain mobiles. If there is a camera also which can track the people's movements, and if they are coming close, it can always give an alarm or give a message across in whatever methods to ensure that they are also in safe distance. And the the most important today also is to track the products or the movement of the materials across. I mean, you have devices today, like whether it's a barcode or a VR code, QR code, various other sorts of devices, tracking devices. This product, these devices can be tracked on the materials right from the vendor's place to the logistics to the shop, into the factory, then after the production to the outside, and then to the dealers and to the customers. So this end to end can be used, can be automated seamlessly using these devices, and you can know the entire sequence and process, and also the lean manufacturing steps in to eliminate unnecessary tasks and improve efficiency on the entire process. Another method, not only to do safe distancing but also to ensure improve efficiency. I would say not the last but not the least is the customer interfacing. We talked about supply chain, we talked about the shop floor activities. Most important is the customer interfacing also. Today, if you see, the dealers are more or less everything is getting virtual. Today, the cars, today you can use virtual reality to do test driving, to look at the features of the car. You can actually sit in the car and observe what are the features function, how are the features function, and what are the benefits of the features. And you can also do a test drive today in VR. So entire, I would be looking at another 2 to 3 years from now, and it's already being faced in the market today that the dealers would be getting virtual and they would be all totally online across. So these are a couple of examples which organization could leverage across and move into back to the workplace, maintaining safe distance. Not only that, they can also improve effectiveness and efficiency. And as Mr. Nath mentioned, the automation is not going to increase cost, which is a wrong perception of the people. It would actually improve cost efficiency on scalable volume. This would be I'm sure that I would have covered all the aspects across, Sandeep.
Sure, Manohar. I think that's been quite insightful. You've touched upon social distancing. You've touched upon the AR/VR based training, how AR/VR can also be used to quickly ramp up the people as well as setting up those machines. You also talked about visual inspection. So if I just quickly look at the discussion that we have had so far, between you, Manohar, and Rajesh, there are various use cases, that you have talked about, which are very much relevant for the industry. That brings me to the next question, which is, what role do you see of the startups in, accelerating the innovation around these areas and solving the business problems?
Right. Very good question, Sandeep. And I think startups certainly have an important role in the manufacturing industry also. So, what are the benefits or what are the advantages of a startup, Sandeep? Basically, they are quite agile, they are flexible. Young people looking at good solution, innovative solutions, thinking out of the box. And I think one of the advantages, they do not carry the load with them. So like larger companies normally have a lot of restriction, constraints. Startups are free in that sense. They are quite agile. And I think in a way I would, Sandeep, if we have to equate it, I would say startups could be like, we say, cobots are going to be the extended arm of humans. So for the engineering company, for the manufacturing companies, I would say startups can also play a role as important as an extended arm. So certain problems could be given to startups and which require a fast solution, a quick solution. And I think that is where we would see the benefit of startups really helping the engineering industry, helping the manufacturing industry, working together like SAP works with a lot of startups. And I think that's a perfect model because it's like closing the loop. You have the companies, you have SAP, and then you have the startups all working together to really help in and I think give solutions, cost effective solutions. And that is what we are looking at solutions which are cost effective. And that can be, I think, surely startups can play a important role here. I don't know, Manohar, would you like to add something to that?
Yeah, that's very far. That's a very good input, Rajesh. That the startups need to have that flexibility and agility to move forward. But also, I would suggest, Sandeep, is today. When you look at the startup panorama, it's more focused on the B2C segment. A lot of activities are happening on the B2C. And the B2B activities, especially on the factory side, automation side, what I called it the ER&D, engineering R&D activities, startups could play a big role in helping the factories to look at how they can improve themselves and help the organization so grow, synergizing the advantage what a startup brings, what Mr. Nath said, and also to bring in their domain competence to grow the organizations across. A typical, I mean, what I would say, look at today's startup as to, I mean, my suggestion or advice would be a startup should need to go spend time in the factory, understand what are the pain areas or problem statements that the factory head or the plant head can give to them, and try to work on a sort of MVP, a minimum viable product to them, so that the product MVP helps the organization in terms of, and this product can be customized to various organizations. See, today what is happening is a startup fears going to a factory automation because a solution is very customized to only to that factory, and it could not be broad based, it could not be generic based. So the organization or the startup could be like to focus on developing a minimum viable product or bare product that's a generic product, and then top it up with the solutions that, I mean, the customization that the current organization needs, and generically try to broad base it as a product on the to the market across. So that way what they would happen, they would also provide a solution to this organization, also develop a product across to the entire society, I mean, to the entire engineering industry. So in this case, I would say that products like solutions, I mean, the tools like digital twins could play a big role in trying to conceptualize the products today. Today, digital twins, people feel it very expensive, but I think the organizations today are using, giving it across on a cloud base. I'm sure SAP would also look at how it could be done across on the entire. So these, with the digital twin, the product development, and with organizations like SAP providing the entire process chain, right from SEM to ERP to CRM, the demand chain. So the entire digital model can be developed by the organizations, by the startup, to visualize how an organization would look, and both the effectiveness and the efficiency, and try to provide. And this is where they can put in their products or the solutions and try to build up on that across. I would say this would be a big role for startups to play in the engineering industry in the days to come. Yeah.
Great. That's wonderful advice, Manohar. I'm sure the startups which are listening to this conversation would definitely take a note of it. And Rajesh, I really like your analogy of equating the startups with the cobots. That's a great analogy. That brings me to my last question for Rajesh, which is, how do you see automation enabling growth in the MSME sector? What are the measures to ensure that the technology becomes the mainstream across MSMEs?
Right. Thank you for the question, Sandeep. It's a very valid, very important question, and I think a very deep question also. A question that is very close to my heart also, especially this topic of MSME and automation. Let me try to keep it simple, Sandeep. Just let's have a look at if we take the scenario of the MSME sector. Sandeep, we have in India, there are 63.34 million MSMEs in India. And a large number, almost you could say 99%, are the micro enterprises. Now, MSMEs employ something like 120 million people and contribute 30% to our GDP, 50% to the exports, and are, I would say, an important or the backbone of the Indian economy. Now, what are the apprehensions in the mind of MSME when we talk about automation? First is certainly the cost factor. Then second is this apprehension that if I have an automated system, if something happens, I do not have trained manpower. How can I handle the disruptions in the system? And there is also fear that if anything goes wrong, I would not really be able to give a solution or come with a solution fast. Now, I think the need of the hour, Sandeep, is for the MSMEs to identify certain critical operations in their process. What are certain critical operations? And then look at baby steps, I would say. I again emphasize, look at simplified solutions, baby steps, and implement these automation solutions, which are cost-effective, simple solutions, but which can give them a faster return of investment, because that is very important for the MSME to get a faster return of investment. If we look at also a typical scenario, Sandeep, remote monitoring. Now, for remote monitoring, you do not have to really spend too much. It's a part of, if you look at Industry 4.0 remote monitoring possibilities of predictive maintenance, they can draw the data out of the machine, analyze the data, and the importance is use this data intelligently, because before the breakdown of the machine happens, if you can take remedial steps, if you can take preventive steps, then you would avoid the breakdown of the machine happening, and this would help to increase your productivity. This would help to make products at a better cost, more cost efficient products. And I think this is going to be the cutting edge. What the SMEs require is to make products at a better price, at better productivity and better efficiency. And let me just conclude, Sandeep. I would like to draw the aspect of 3 R's for the MSME sector. Response. Now, COVID has seen we had the response factor. Then the second R, I would say, recover. And that is where, in this particular situation, the MSMEs have to recover from the disruptions due to COVID, the business disruptions due to COVID. And recovery phase is an important phase, because now is the time they should really look at automation solutions, simplified automation solutions, which they can implement. And the third R, which is very important, is resilience. The MSMEs require to build the resilience now if they have to move ahead and build their businesses for the future. So I think these 3 R's are going to be very important for the MSMEs and for India as a country. The role of the MSME is very important. So we can only progress when our SMEs progress. And for that, automation is very essential. Thank you, Sandeep.
Great, Rajesh. I guess the 3 R's, respond, recover, and resilience. I guess that's a great advice for the MSMEs. So, ladies and gentlemen, that brings us to the close of this conversation. Mr. Rajesh and Mr. Manohar, thank you very much. It was an
Thank you.
honor, having you here.
Pleasure for us. Thank you.
Pleasure. Thank you. Thank you.
Great. With this, now I would like to hand over to my colleague Justin, who leads the startup studio, and he's going to share. In fact, he's actually lined up interesting stories for us. So, with that, Justin, over to you.
Thanks, Sandeep, for moderating an insightful conversation with the industry experts from VDMA. This truly sets the perfect context for the reminder part of this event today. Before we move into the detailed demos, I would like to quickly touch upon SAP's startup engagement in India, called SAP Startup Studio. As part of this program, we offer technology infrastructure, technology guidance, and go-to-market readiness to entrepreneurs who's developing products complement SAP's offerings. This program serves as a key platform for SAP to engage with customers such as yours within the India market unit through startup innovations powered by SAP technologies. This one slider, which you see on the screen right now, essentially captures the snapshot of our engagement thus far. Over the due course of next 45 to 50 minutes, we will be presenting to you 5 compelling innovations which could significantly impact your frontline. Without further ado, let me get started on this front. In this regard, I would like to invite Mitali Mishra, CTO and Head Digital Solutions at Expert Global, to talk about their solutions in the space of remote monitoring and control of production and workforce productivity. EGS has been a partner of SAP Co-Innovation Labs Bangalore for over the past 2 years, and they've had a fantastic journey with us. Over to you, Mitali, to talk more about what you do at EGS.
Hi, thanks, Justin, and welcome everybody to this very interesting session on the various innovations in the field of Industry 4.0. What I'm going to present is the innovation which EGS has worked on with SAP Co-Innovation Lab Bangalore, that is Machine Talk. So, Machine Talk basically is a machine-to-machine communication and Industry 4.0 platform for smart shop floors. Before we get into the details of the product, maybe a quick introduction to what Expert Global stands for. Expert Global is now almost 30 years in business. We are an engineering and IT services and solutions company. We provide digital and engineering solutions to our customers, which are globally present. These are Fortune 100, Fortune 400, 500 customers. The company has a very rich history of almost 30 years with very strategic and forward looking approach and fostering sustainable growth. Of course, as you can see, it's almost 30 years we have been hearing about startups and the agility that the startups should bring. So I would like to focus upon this point a bit more. That even though 30 years in business, I think Expert Global has created a platform which fosters innovation quite a lot. And with this, we every division is trying to bring in this level of flexibility, this level of agility for our customers to help achieve the bottom lines, to help achieve the speed of response, and develop interesting solutions to solve business problems. Uh, Going to some of the challenges which are very unique to be solved with industry 4.0, and I think in the discussion just before, a lot of topics have already been touched upon, and that makes it much simpler to really pinpoint what are the challenges that we are trying to solve with this product. So typically in discrete manufacturing or on any shop floor, we see that there is a lot of information which is available, there's a lot of data which is available. However, the aspect of correctness of information is sometimes missing. The information might not always be real time, so the data is available, however you have very poor visibility into this data. The trust, lack of trust happens because you are not sure if you're looking at the latest and the greatest versions of Excel spreadsheets. The processes are manual, which leads to a lot of errors, and there is a limited control on overall process. So what industry 4.0 can really help with is bring in this real time aspect of integrating the top flows to the shop floors, making this data available at a click of a button at any given point in time, and irrespective of where your location is. The kind of use cases that industry 4.0 brings in, and machine talk is trying to solve, is rather having digital performance management, which can be enabled remotely, having remote asset control to really take control of your assets in through a remote location, working on waste reduction, so reducing the scrap which is produced as part of a byproduct of the process, and also as part of quality rejections, which leads to a lot of reworks. uh, Working on maintenance cycle, so really bringing in predictability into the maintenance, so working on condition based monitoring, and also predicting the part of when maintenance is needed, and thereby enabling increase of the maintenance cycle. So not really doing maintenance when it is scheduled, but based on the condition and the prediction of a failure in the equipment. Making IIoT based asset optimization possible, and also working on inline process optimizations. So these are some of the use cases which machine talk can really help with and can enable. Talking about what are the various components of machine talk and how it is structured. So what you're seeing on your screens is really a very high level architecture diagram of how machine talk is. So you have equipments of the shop floor, which have PLCs, SCADAs, sensors connected to it. So you can talk about semi-automated equipments, automated equipments, and fairly manual processes. And these equipments are capable of producing a lot of important data for you. So, for example, the vibration signature of your equipment or the temperature levels of the coolant are very, very important details which the machine is communicating to you, based on which you can take insightful actions. So, you have these equipments and this data on the shop floor. The machine talk solution comes in three major components, which is machine talk device, which works on acquiring this data from these equipments. Then we have the machine talk gateway, which helps bring this data from your shop floor environments to the cloud environments. And then we have the actual core component, which is working on this data in real time and bringing in lot of insights which enable fact-based controls and decisions that can be taken on the equipment. So it really kind of brings in an integrated approach to collect the data, to present this data, to analyze this data, and further enable deep learning on this data to build predictability. Predictability of maintenance, predictability of quality, predictability of cost. So these are the various aspects that the solution really brings to the table. So if we look at the main components of the solution, or the main highlights of the solution, it is really built on 7 building blocks. So first is connect the machines, sensors, PLCs, SCADAs, ERP data, non-ERP data into a common platform. Acquire this data using the unified data acquisition techniques. Store this data so that you can look at the data historically and also build redundancy into the data sets that are available. Analyze this data for trends, for recommendations that you need in the day-to-day work on shop floors, for alerts and notifications that might be needed. Then display this data in meaningful dashboards and meaningful reports for various types of users in the shop floor, be it frontline workers like operators, associates, quality engineers, supervisors, or taking it to the control room where you have the plant heads, managers looking at this data, and maintenance guys looking at that data to the management level. And then predict. So once we have the core components really set, wherein we are acquiring the data, we are storing it in a meaningful fashion, we can really extend it towards predicting it. So looking at the data which is available and looking at the way data has behaved in past, we can predict how the quality would look like, how the cost would look like, and how the maintenance would look like. And then of course the next step is towards controlling, so taking control of your equipment to perform certain operations. Now, as you can see, one of the core building blocks of the solution is really the data acquisition. So how you can really bring in this data from shop floor and abstract it to a level where you can kind of bring in configurability. I think Mr. Manohar in his last session spoke about having a common platform that can be deployed to various various organizations and various types of scenarios. And that's very important aspect, because if you see the shop floors, even with the same equipments, can be configured very differently for different organizations. So it's very important to abstract that low level layer from the high level analytics and analysis layer that comes on the cloud side of things. And that's where we have this machine talk device, which really helps in doing that. Machine talk device can connect to technically and theoretically any type of equipment over a variety of protocols that it supports out of box, like Profinet, Profibus. It supports OPC communication, it supports Modbus, it supports TCP, it supports industrial Ethernet. So virtually, a wide variety of protocols are supported out of box to let it connect to any equipment. It comes with a certain set of analog and digital channels, digital IOs, which help to collect data directly from sensors, and also to the digital outputs help with certain pulses that can be used for triggering alarms and audiovisual beacons in the shop floor. The device comes with its own capacity of about of storage, which helps with ensuring that you are building redundancy, and you are also ensuring that in case of any network failures, in case of any problems that happen on the shop floor, you ensure that there is zero data loss. So that is how the first aspect of acquiring the data from the shop floors is done. The cloud has the complete control, and you can use this cloud to really configure the variety of parameters that you want with a very simple wizard based interface. Now, once these core parameters are defined, you can derive various parameters on top of it. You can set rules and triggers on top of it. You can define your own KPIs. So, it's very interesting how discrete shop floors will monitor OEs, that is overall equipment effectiveness. And even though OE is always a product of availability, product, and quality, different organizations have different methods of calculating OE still. So having that capability to really configure your KPI the way you want is very important. And that's what Machine Talk brings to you. It lets you configure your own KPIs so that you can, it lets you set those formulas, it lets you set how you want to visualize this data and how do you want to make use of this data going forward. So these KPIs are possible. It comes with an out-of-box statistical process control module, which lets you monitor the inline process quality, and plus it gives you multiple reporting views that are available, and you can again configure it with a click of button without writing any line of code. So definitely, it comes with a lot of benefits. It's a plug and play sort of deployment. It's extremely configurable and customizable to your own needs. It brings in intuitive data visualization. It helps with predictive analytics, and definitely it is built on one of the trusted technology platforms, that is SAP, and it hence also enables seamless integration with SAP ERP systems. So that's a brief about what machine talk is, and to really look at how it it is implemented in one of our organizations. I've borrowed one of the case studies from Discrete Manufacturing. So this is an engine manufacturer, and the machines where we have really done this implementation is the milling operation for really boring the shaft diameters. So now if you with they had a lot of pain areas, typically, that the data was not available in real time. There was a lot of time being spent on collecting all the information and looking at this data. They also had difficulties in really analyzing the downtimes and utilization of equipments. And these are really, bottleneck equipments and machines that we are talking about. And if this equipment goes down, the entire line and the production is affected because of that. So it was important to really see why there is a downtime and to work on those reasons of downtime to ensure that availability of the equipment is ensured. And that's where Machine Talk helped them. We implemented the entire solution. The implementation was completed in like right from discovery phase to them getting real time reports from the system in a period of almost just 6 weeks. And all the data was available to them on a click of a button. So their downtime analysis was available, their OE analysis was available, they were able to see their production plans, they were able to relate the equipment utilization with the production plan, they were able to track quality in real times, and all of this really helped them. With the solution, they could really save about 25 hours per month in which was spent in collecting the reports and giving this insight. So now this was available in real time. So imagine 25 hours being spent every month, and that too getting a report for maybe a week later than what was happening today is something which was completely taken care of. One interesting advantage that this organization got is that by design they had always assumed that their cycle time for a certain operation is about 2 minutes. But when the data was captured in real time, they could see that the actual cycle time is really about 30 seconds. So it was ranging between 25 to 30 seconds because it's a manual operation. But 2 minutes and 30 seconds was a great insight that they could really get into how their operations were configured. And because they could see that, yes, they are considering a higher cycle time for an operation that can really be completed in 30 seconds, they could actually double their capacities with the existing equipment itself. So that is the kind of power, or the control that industry 4.0 can bring to your tables, to your hands, that when you really see what is happening on the shop floor and you really capture every minor stoppage, every minor second that is being spent on a operation, you can get the benefits that are needed to maintain your shop floors remotely, to run your shop floors effectively, and get the desired benefits of the investments that have been put into the assets. So that is how industry 4.0 can really help with bringing this data to your hands, so that you can get the desired benefits out of the investments that you have made into assets, and have the ability to remotely control, remotely monitor, and remotely ensure the desired level of performance of your equipment. So thank you.
Thank you, Mitali, for a detailed pitch. I'm sure this Industry 4.0 solution is high on priority for customers in the manufacturing sector, and we are sure this will definitely ring a bell with our audience today.